In this MQP, we present Think Again, a planning pipeline that leverages the generalizability of LLMs and the reliability of classical planners to create safe plans that consider environmental context. As robots and other forms of autonomous systems become increasingly ingrained in everyday life, the ability to plan tasks safely and successfully is vitally important. Unlike other methods that use LLMs to verify safety, our pipeline's LLM is not directly involved in the generation or adjustment of the plan, but instead generates a series of weighted values that are used to inform the final plan generated by the traditional planner. We begin by encoding our labeled environment as a transition system, which models how the robot is able to move throughout it. Using existing methods, we are able to ground a natural language command into a linear temporal logic specification. The specification can then be encoded into a Buki automaton that accepts or rejects depending on the symbols provided to it, which in this case are the environment regions the robot enters. From the Buki automaton and the transition system, the product automaton can be constructed. Once we've successfully calculated the product automaton, we then employ our LLM, deemed paranoia, to weight the edges of the graph based on the environment labels it sees. For the 10 hazards paranoia deems the most important, the danger score used to weight the product automata is calculated by multiplying the probability that the event could occur by the weighted sum of the total low, medium, and high risk of the event to humans and robots. In addition, paranoia also outputs the relevant environment label, allowing us to directly map the scores to the automaton through textual embedding or other methods. These danger scores are then used to weight the environment grid, and from there, our custom A-star algorithm is run, which not only finds the path through the environment, but also does it while ensuring the LTL specification is met. For example, in this demo run on a Hello Robot Stretch 3 in Unity Hall, we set up a task that requires the robot to pick up a DoorDash delivery, navigating from the Automata Lab to the hallway. In the first instance, the robot avoids areas specified in the LTL task, which for visibility is sectioned off by tape on the floor, and plans a path to the door that is further away, yet avoids high-risk areas such as those usually crowded by students testing hardware. In addition, once the robot has picked up the order, paranoia weighs the areas that could be damaged by spilled food or drink much higher than before, and the robot subsequently plans around those labels even though it successfully traversed through them previously. We prove the efficacy of our method in both simulation and on real robot hardware, deploying Think Again in a variety of different environments and scenarios. Our pipeline is able to adapt to the context of both its given task and the environment, navigating around or avoiding risky areas entirely, while still ensuring plan success and following rigid requirements.